Good afternoon, everyone. Welcome to the live webinar organized by Indian Cybersecurity Solutions. Today, we are having Mr. Debashish Roy, who is a certified Cisco trainer and is having 20 years of experience and more than that. He is also an expert in the field of cloud computing and is having various experiences in AWS, Azure, and many other fields. Debashish sir, over to you.
Thanks. Hello, everybody. My name is Debashish Roy. I'm the senior network trainer as well as Cisco network specialist at the Indian Cybersecurity Solutions. And these are my contact informations for LinkedIn and Twitter, both of my personal information and company information, in case you want to contact me. Today, the topic that I've come up with is EIGRP, unequal cost load balancing. That is a very important topic for CCNP enterprise, and that is a topic for NRC, the Advanced Routing Services paper. So, what is load balancing after all? Load balancing means to send some packets to more than one link at same time. So if you have two links, then EIGRP can send some packets to link 1 and the other packets to link 2. And it will be done to reduce the load on only one link. See, if you are using only one link to send the data packet, then that link will have the 100% load. And definitely the bandwidth of that link will go low and the link will fail. So definitely we do not want that protocol like EIGRP, that is a Cisco proprietary protocol, not proprietary now, but it was for some time. So we do not want the EIGRP to send that link, send the package to only one link, and that link will fail. So to avoid that, you must do the load balancing. Now, load balancing, how it is performed? Load balancing is performed according to the path metric. So we know that every routing protocol, say EIGRP or OSPF or previously RIP, BGP, these protocols, everybody follows some path metric to calculate the best path. So load balancing is definitely done according to the path metrics. Now, EIGRP performs equal metric load balancing or equal cost load balancing across maximum up to 6 paths. So, by default, it is equal cost load balancing in case of EIGRP, not unequal. We have to configure the unequal cost load balancing, but by default, it is not done. By default, we only get equal metric or equal cost load balancing in case of EIGRP and across how many paths maximum? Maximum up to 6 paths. By default, it is done in 4 paths and it can go up to 6 paths. It means that if the metric is same for all the links, so we already know that EIGRP uses a composite metric of bandwidth and delay. So using that metric, using that composite metric, if the metric or the cost is equal in all say 2 or 3 links, so in that case that is equal cost load balancing. And if the cost or metric is unequal, if the metric value is unequal, one link is having 10 and one link is having 20, that is a different metric, that is unequal cost. Now, EIGRP can load balance across unequal cost paths also, and that is a unique feature for EIGRP because previously the previous routing protocols, RIP, Routing Information Protocol, or OSPF, Open Shortest Path First, these protocols didn't do unequal cost load balancing. They only did equal cost load balancing. But EIGRP supports both equal and also unequal cost load balancing. Now, before going to the load balancing, the variance configuration, we need to first understand these concepts. Otherwise, we cannot do the load balancing. These are very important concepts like successor, feasible distance, and reported distance. These 4 terms are very important. First, successor. This is the best route to send the EIGRP traffic. So according to the metric value, the route which has the best metric, or you should say the lowest metric value, that route would be the successor route. So this is the primary link that the EIGRP will use to send the traffic. This is the best route or the base path, you can say. Base path is the successor route. Which is the feasible successor? Feasible successor is a backup route or the secondary route, a redundant route for sending traffic. So if the successor route is up, the feasible successor will never be used. As long as successor route is there, feasible successor will never be used. But if the successor route fails, then feasible successor will be installed in routing table, and then the traffic will be sent across the feasible successor route. So if the successor route goes down, the theory is like that, then EIGRP will calculate the other backup links and it will elect the link as the feasible successor. And definitely there are also some conditions to be elected as the feasible successor. We'll go into that later. Feasible distance. This is the metric of the successor route, the best metric. This is the best metric of the best path. So successor's metric is known as the feasible distance. This is the lowest metric. Now the fourth thing is reported distance, or we say sometimes as advertised distance. This is the metric as reported by the neighbor. So if one router is connected to the other router, so if that router means R2 is reporting or advertising a distance or a metric to R1, then it will be known as reported distance. We will also see it in action sometimes later. Now, this is an example to understand that. Now, see, there are R1, R2, R3, R4, and R5. Now, these are the values, the metrics 5, 500, 9, 5, 10, and 5. This is your destination. And the metric to a destination to R5, from R5 to destination is 5. Now, in case of feasible distance, see, feasible distance, or that is the total thing, this from R1 to R5 via R2, if you want to calculate the feasible distance, it will be this 5 plus 10 plus 5 means 15 plus 5 means 20. So the entire thing, 5 plus 5 plus 5, 10 plus 5, 15, and 100 plus 9, 109 and 5, 114. That will be the entire path distance, entire path metric, should I call it. That is the feasible distance, or and the reported distance or advertised distance, that is this thing, the distance reported by R2. R2 is reporting 10 plus 5, this 15. This distance or this metric to R1. R3 is reporting 5 plus 5, 10 to R1. R4 is reporting 9, 5 plus 5 to R1. So this one, these individual segments from R2, R3 and R4 neighbors respectively, this is your RD or reported distance or advertised distance, and the total is the feasible distance. And you can see here also next reported distance and feasible distance, that is also given. That feasible distance, this is the total thing, like R2 20 and R3 15 and R4 114 that I've already told you, and reported distance is a smaller part that is reported from the neighbor. And now, so we are already done with the reported distance and the feasible distance configurations. Now, let me tell you who will be the successor and feasible successor. Now, the successor will be the best path. According to what? According to reported distance? No. According to the feasible distance. Now, this is 15. This is the lowest feasible distance. So, the path via R3 will be elected as a successor. And why this path via R4 is feasible successor, not via R2? Because see, this R4's reported distance, this 14, is lesser than the feasible distance of the successor route, that is 15. So the reported distance of a router should be lesser than the feasible distance of the successor. It cannot be equal also. It should be lesser than the feasible distance of the successor to be elected as a feasible successor. That is why R4 is feasible successor, because see, the reported distance of R2 is 15, which is equal to the feasible distance of the R3. So it is not qualified as a feasible successor. Only R4 is qualified as a feasible successor. Now, there is a variance multiplier. What is that? EIGRP uses variance value or the variance multiplier to load balance across the unequal metric paths. So by default, I've told you that EIGRP does the equal cost load balancing, but you have to configure the unequal cost load balancing actually. So you have to configure variance multiplier for that. And the variance value ranges from 1 to 128. Now, to calculate the variance value, the formula is FD, feasible distance of feasible successor. Very important, feasible distance of feasible successor should be less than the feasible distance of successor into the variance multiplier. So if you want to load balance across all the unequal cost links, then you have to put a variance multiplier, and the feasible distance of feasible successor should be less than that feasible distance of successor into the variance multiplier value. That is the thing. So that is the theory part for this variance value. And now I will show you how to configure the unequal cost load balancing across the routers. For that, we will take the help of the GNS3 simulator. So here you can see that there are many routers in the GNS3. It is already configured like R1, R2, R3, R4, R5, all routers are there. Now, if I go to R1, see, these are already configured. The EIGRP is already running. And now if you go to R1 and if you give the command show IP route and first verify if the IP routes are there, yes, you can see that definitely these IP routes denoted as D as the EIGRP 5000. Now, this is the main part for us. We want to actually go to the loopback interface of the R3. R3 route has a loopback interface that is 5001. So we need to go to that network from R1 and see we have two paths, and these are not equal cost paths anyway. These are unequal cost paths. Say one is having the metric of 158720 and one is having the metric of 412160. So definitely you can say that the lower metric cost is 158720. Now if I want to see in more details, say show IP route, then you give this 5001. So if I give that, See, you have these two only. One is through 3.2 and one is through 1.2. So the lowest metric, that is 158720, to the 1.2, 1.2 means to this. So that will be our successor root. If you verify with this command also, show EIGRP topology, and not only topology, but then you have to give all hyphen links. So I think that is show IP EIGRP topology anyway. Just a minute. Yes. So in case of show IP topology, all links, you can see it in details. The successor and the visible successors. See, in case of 500, you have one successor only, because see, that is the metric value, which is the lowest metric. Lowest visible distance is through 1.2, 192.1.2 that I have already told you. The metric value is this 158720. This is your successor. And now, who will be your feasible successor? See, the feasible successors condition is that RD, or the reported distance, should be lower than the feasible distance of the successor. Now, who qualifies? See, this via 5.2, this as a reported distance, it reports as 156160. Is it lower than this value 158720? Definitely it has. So it is also a feasible successor. Also, this 156160, this also is lower than the 158720. So that is also known as a feasible successor. So both qualifies as a feasible successor. So in that case, if both the links through serial 4x0 and Ethernet 3x0, both links qualify to be the feasible successor, we need to configure the load balancing, unequal cost load balancing, through via 5.2 and via 3.2. So in that case, a variance multiplier is needed, because by default, EIGRP will not load balance across these unequal cost links. So how to do it? See, in our case, the variance multiplier is needed. That is almost 3. Multiplier variance value will be 3. Why? Because see, the highest metric here through 3.2, that is 412160. And if you divide 412160 by, if you divide by this, the feasible distance of the successor, so 412160 by 158720, if you do the simple calculation, it comes almost around 3. So we have to give the variance multiplier value of 3 in order to load balance across all the three paths to 1.2, that is the successor, and 5.2, 3.2, all the three paths. And now let's configure it. You go to the router 1 and go to the EIGRP, router EIGRP, and the autonomous system is one here that we are following, and you give variance as 3. So variance 3 is configured on the R1, and now you verify. You can give show IP root, and you can see in this case, say you give See, it is 3.2. It is done by 3.2 and 1.2 also. So in this case of variance, you can check to IPIGIP topology or links, and here you can see that now it has included the 5.2. This all through all the links the traffic will go. So if you give the variance 3 multiplier, so you can say that the load balancing is achieved by both the links, both the feasible successors that is done. You can also check it by show IP route 5.0.0.0. You can say that the load balancing is 3.2 and 1.2. All is achieving the load balancing across the unequal cost links. So this is about the unequal cost load balancing using the variance multiplier that I've shown you in practically how to configure variance. And also I've discussed the theory part also. So I think it was informative for you, and I think you have enjoyed this. And thanks for joining this webinar. And I highly recommend this NRC, this advanced routing paper for CCNP, and the entire CCNP enterprise goes to everybody who is familiar with Cisco routing and switching. So NRC enterprise, CCNP enterprise actually will give you an extra edge to your career definitely, and will boost your career. So definitely you should enroll in the CCNP enterprise course right now. So thanks for watching this webinar on this EIGRP, load balancing and variance. And I'll come with some other topic other day. So thank you for joining this webinar. I hope it was informative for you. And if you like more videos and webinars like this, so please go to our YouTube channel and like this video, like this webinar, and also subscribe our channel to get more webinar informations like this in future. So thanks for joining this webinar, and I wish you good luck for the future for the Cisco networking. Over to
Thank you,
Ali.
sir. It was quite informative. Viewers, if you are having any doubt, you can contact sir, or you can mail us at info@indiancybersecurity.solutions.com. Thank you, sir. Thank you, everyone.
Thank you.
See you again.